Good morning. I am Dr. Satish, Professor and Head of Department of Conservative Dentistry and Endodontics. Today I am going to talk about the topic of direct filling gold. I am going to talk about the following contents regarding direct filling gold, like the introduction, definition, the properties of the gold, indications, contraindications, advantages, disadvantages, the classification and forms of direct filling gold, annealing, degassing, compaction, methods and techniques, and advancements, and decline of the gold restorations, and conclusion. Introduction. Definition. According to Sturdivant, direct filling gold are those restorative materials that are manufactured for compaction directly into the prepared cavities. A properly placed direct filling gold material can yield excellent long-lasting restorations. Gold as restorative material in dentistry is in use since ages. Properties. Noble metal. It's a noble metal. It fuses at 1063 degrees centigrade and boils at 2200 degrees centigrade. It is ductile, it is malleable. The density of pure gold is 19.3 grams per centimeter cube. The brittle hardness number is 25, but cold working increases the hardness to 58 to 82. The tensile stress after cold working increases to 19,000 psi to 32,000 psi. The yield strength increases from 0 to 30,000 psi. It's got high thermal conductivity of 0.71 calories per second per centimeter square. It is chemically inactive and it is not affected by heat, moisture and most solvents. It can be cold worked and welded at room temperature. It's efficient sealing restorative material. The coefficient of expansion is 14.4, that is near to 11.4 to the 10 to 10 to the power of minus 6, the coefficient of the expansion of the tooth. Indications. Gold is a non-aesthetic, indicated in the non-aesthetic and low stress areas, in lesions of very limited dimensions and extent, in lesions in which cavity margins are located on sound enamel surface, lesions in vital teeth, patients with good oral hygiene, lesions with adequate access for detailed preparation, areas necessary to repair perforations in case of gold alloy restorations, teeth with no enamel crazing or micro cracks, lesions in which adequate tooth structure is left after removal of diseased tissues. The contraindications are that gold cannot be used in teeth with large pulpal chambers like young patients, periodontally weakened teeth, large carious lesions, handicapped and elderly patients, psychologically unsound patients, heavy occlusal stresses. It's having a disadvantage of economics, aesthetics, inaccessible areas, no isolations, high caries index, hypoplastic areas, and if the teeth are not completely formed. Advantages are it has got most permanent method of repairing individual teeth. It's a noble metal, so won't tarnish and corrode. Direct filling gold is insoluble and has thermal expansion similar to that of dentine. No tooth discoloration, good adaptation and inert qualities. Surface can be polished well, smoothness lasts indefinitely, so minimal plaque accumulation, malleable and ductile, so excellent marginal integrity. High wear resistance, direct gold adapts well to the cavity wall. In addition to no cementing medium is necessary for the retention of restoration. The disadvantages are it has got a yellow color, it is anesthetic, thermal conductivity can be a problem in newly restored teeth, patient discomfort will be reduced in few weeks as protective dentin forms and insulates the pulp, or else you can give cement base under direct filling gold restorations. Manipulation of gold is difficult to many and requires skill and practice. It's highly technique sensitive. It consumes time, it's a time consuming procedure, it's high cost factor, high condensation force, may injure the tooth and supporting tissues, and it is also got galvanism. The annealing or degassing is a controlled heating and cooling process designed to produce desired properties in the metal by Anusavis. Cold welding is the process of plastically deforming a metal, usually at room temperature, accompanied by strain hardening. This is also by Anusavis. The proper desorption is a matter of heating long enough at a temperature that removes gases, and in case of powdered gold, burns away the wax. Removal of surface contaminants for non-cohesive gold degassing is done to remove protective ammonia film. The temperature of the gold is 650 to 700 degrees centigrade. Purpose is to produce an anatomically clean surface to make the material cohesive. There are two ways of annealing. One is an alcohol flame and the other is electrolytic annealers. Alcohol flame is again divided into piece method and bulk annealing. You can see the pictures in which single piece is heated up along with the forceps, and there are multiple pieces heated in a bulk format on the plate of the burner. Electrolytic burner, you can see the picture here, which shows the multiple gold pieces where they are heated on an electric furnace. Alcohol flame is preferred method, less danger of contamination as compared to the gas. 90% ethyl or methyl alcohol without any additives is used. Acetone free alcohol must be used to prevent contamination. Middle region of the flame is used for heating. Dull cherry red. It takes 15 to 20 seconds for the complete degassing. Next is the piece method. A single piece is annealed at one time, usually done by the dental assistant, and the gold is carried and held with nichrome wire since it does not interfere with the cleaning process. Advantages is its negligible waste, ability to select a desired size of the gold, eliminates contamination among different pellets, heating and use. Next, we are going to talk about bulk annealing. It is done by using electric or gas of heat, degassing of several gold pellets at the same time. It takes 5 minutes for the process. Mica trays are used to hold the gold over the flame, dull red color, and it is advantages is it takes less time when compared to the piece method. Disadvantages: danger of over annealing, and gold pellets may stick together if moved during the heating. Air currents may cause unequal heating. You can see the picture here where the bulk annealing is done on the furnace. Next is the chairside test to test cohesion of the gold. Press two pieces of annealed gold together with a flat instrument. If uncontaminated and properly annealed, they should stick to each other. Compaction or condensation of the gold is a procedure used to condense and harden the gold inside the cavity preparation. The objectives is cohere two pieces of gold to each other. This is called as welding. To wedge the initial pieces between the dentinal walls, especially at starting points, to minimize the voids in general, and to eliminate them from the critical areas like margins and surfaces. Cold working or strain hardening hardens the gold mass and increases its strength during condensation. Adapt the gold to the cavity walls and floor, bringing the material close to the cavity walls. What are the principles of condensation? Line of force, stepping, force of the blow, condenses. The recommended force is 15 pounds per square feet. The line of force is the angle of force. It must be at 45 degrees up to the cavity walls and floors. The force of condensation should be at 90 degrees to previously condensed gold. Avoid any loosening or displacement of already condensed gold piece. Line of force should bisect line angles and trisect point angles. What if incorrect angulation? The segment may become loose and get dislodged. What if incorrect angulation? It becomes loose and it gets dislodged. Stepping method is the process of overlapping the half or 1/4 of already condensed gold. The condenser is overlapping the gold already condensed once. You can see the diagram in which the stepping pattern of the condenser is put. What if the stepping not done properly? The mass will be poorly condensed and it will have a pitted or are likely to fail. What are the force of the blow? Too strong a force will perforate the gold and damage the pulp. Too light a force is inadequate compaction or poor adaptation, restoration of full voids. The factors which control the force are the weight of the hammer and velocity with which it is brought down on the condenser, resistance of the substance receiving the blow, area of condenser point in contact with the restoration. Larger diameter nibs require greater force and when compared to the smaller ones, as the diameter is doubled and increases to 4 times. So the P is equal to force per area. The small condenser tips are 0.5 to 1 mm and are used for the compaction. Condensers, pluggers, these are the different types of condensers where we use to deliver the forces of compaction. They are round condensers, parallelogram condensers and foot condensers. Round condensers to start gold restoration and to create ties in inner parts of the restoration, recommended 0.5 to 1 mm diameter. And the parallelogram condensers are to create the bulk of the restoration. Foot condensers are for KO surface condensation and surface hardening of restoration and for bulk buildup. These are the different kinds of condensers which are present. You can see the pictures wherein all the condensers are placed in an order. Complete set of Loma Linda hand condensing instruments of direct filling gold. These are the set of hand condensing instruments. There is a hatchet condenser, you can see the face of the hatchet. Foot condenser, you can see the face of the foot condenser. The hand pressure. Use of this method is normally contraindicated as it takes much force. Indicated to adapt the first piece of gold only. Powdered gold is best condensed with hand pressure. Small diameter condensers are used. The nichrome wire used for carrying gold is a pneumatic condenser is also there, and detachable condensing tips are also there in the pneumatic condenser. The compaction technique is general steps for insertion is the 3 steps to build up for the restoration is tie formation, banking of the walls and shoulder formation, and paving of the restoration. Surface hardening of the restoration, burnishing, margination, burnishing, contouring, finishing and polishing. These are the steps of condensation. The general steps for insertion. 3 steps are built up for the restoration. The tie formation is the connecting of 2 opposite point angles with a transverse bar of gold. This tie forms the foundation of any direct gold. You can see the pictures where the tie is formed. And then we come to the banking of the walls, covering each wall from its floor or axial wall to cable surface margin with direct gold. The wall is banked without obstructing tie formation or banking of the other walls. It is done simultaneously on other walls too. Shoulder formation. To complete a built up, 2 opposing walls are connected with the direct filling gold. Then you pave the restoration. Paving of the restoration is done by every area of cable surface margin is individually covered with excess gold foil, and condensation from center to periphery is better than periphery to center since it decreases the trapped air bubbles. You can see the first gold pellet being condensed into the point angle here in the picture, and the rocking motion of the instrument condensing the gold. What is surface hardening of the restoration? Condensation from center to periphery. Condensation of the precipitated type of gold should be started by hand, then rest is done by mechanical process. Burnishing, done from moving gold to tooth surface. This enhances the surface hardening and will adapt the gold to the margins. Margination is done by knives, files, moving from gold to the tooth surface, eliminating the small increments. Then you get to the burnishing, close marginal discrepancies as well as strain hardening the surface, contouring with files, knives, and finishing burrs to create proper anatomy of the restoration to coincide with that of the tooth. Finishing and polishing is done with the precipitated chalk and tin oxide powder with soft brushes and rubber cups. What are the advancements in gold? Stop F Gold is the newly formed introduced in 1989 by DL and Ringel Steen. It is manufactured from a chemically precipitated gold powder that underwent a milling process after precipitation. The individual particles are then loosely sintered together and cut into strips of 3 mm wide and 40 mm in length. Available in 3 different thicknesses of 0.7, 1 mm and 1.5 mm respectively. Microscopically, it consists of a flat polygonal diameter of 20 to 25 to 75 micron meters and thickness of 1.5 mm. Easy Gold is the next one. Easy Gold is also called as Easy Gold, and it is new type of gold dent. It is a type of powdered gold with less than 0.01 organic wax that can be hand condensed. It shows the property of amalgam in stiffness and is more cohesive than other forms of the gold. Its chief advantage is easy manipulation. Next is the decline of gold restorations. Why was there a decline of gold restoration? Because of the patient factors, operative factors, material factors. In patient factors, you have the aesthetics, high cost, time consuming procedure, discomfort, galvanic pain, allergy, normally very rare. The operative factors are necessity for the higher skill, lure of cosmetic dentistry, need for more chairside time, possible periodontal damage, possible damage in enamel margins, and extra care during degassing. Material factors are poor aesthetics, costly, high thermal conductivity, possible galvanic current, softness of the pure gold, higher density, so more costly and heavier, evolution of newer materials. Conclusion: direct gold tooth is compacted properly into sound tooth structure and with only minimal pulpal response. However, the technical skill of the dentist is of paramount importance to success. Direct gold restoration of poor quality can improve to be one of the most inferior of all clinical restorations. The proper insertion of direct gold restorations challenges the technical proficiency of the dentist, as does no other type of restorations. So these are my references. I have referred from Anusavis, Craig's Restorative Dental Materials, textbook of Modern Operative Dentistry and Modern Theory by Mazuk, and Sturdivant's Art and Science of Operative Dentistry, and also the web. Thank you.